How are you, grade 10? I hope you are fine. Today we're going to complete our revision sheet for the fourth quarter, part 2. I hope you solve already part 1 by yourself and check your answers from the last video. Let's open your revision sheet with me and let's try to solve to complete it. Last session we finished till number 13. Now we are going to start from number 14. Tell whether the transformation appears to be a reflection. What we said about reflection, if you remember, that reflection, I must have a reflection line. Okay, reflection line. Very good. And each point had the same distance from the reflection line. Okay, so, and the figure is flipped across the line. So, is this reflection line, the figure flipped across the line? Yes. So this is what? Reflection. This is reflection. Very good. So a reflection is a transformation that moves a figure or the pre-image by flipping it across a line. Okay, very nice. Let's complete this. 15. Which statement correctly describes a step in a process of drawing reflection? If you remember, when we get to draw the reflection, what we are going to do? We're going to make, do you remember? Each point, I'm going to make what? Parallel? Perpendicular, sorry. We're going to make perpendicular points. Sorry. We're going to make perpendicular lines. Okay, remember? We're going to make perpendicular lines from each vertices. Okay, here perpendicular lines from each vertices. Here, perpendicular line. Perpendicular to what? Do you remember? Perpendicular to the reflection line. Here, perpendicular to the reflection line. Okay, and we are going to take the same distance. This distance equal this one. If this is 1 centimeter, so this will be 1 centimeter. If this 5 centimeters, so all of this 5 centimeter. Okay. If this 2 centimeter, this will be 2 centimeter. Okay. Then after we put the each point, what we're going to do, we're going to connect the points to form the image. Okay. Remember now? So let's see here. Through each vertex, draw a line perpendicular to the reflection of line. Yes. So first one is right. Let's complete to see. Measure the distance from each vertex to the line of reflection. Locate the image of each vertex on the same side. Look here. The image is in the other side, not in the same side. Okay. So it's not in the same side. Okay. Very good. Connect the pre-image of the vertices. We're going to connect the pre-image? No, the pre-image already connected. We connect what? The image. Okay, very good. Measure the distance from each vertex to the line of reflection. Yes. Locate the pre-image of each vertex on the opposite side of the reflection and the same distance from it. Are we going to do this? Measure the distance from each vertex to the line of reflection and locate the pre-image of each vertex. Of course not. So, what is the right? It will be what? A. Okay? Very good. So here we're going to locate, not locating the pre-image. Pre-image already located. We're going to locate the image. Okay, so D is not the answer, so A is the answer. Okay, very good. Let's complete number 16. Reflect the figure vertices. He gives you A, B, and C, and D across the x-axis. Reflection across the x-axis. How we are going to do this? Do you remember the rule? What is the rule of reflection of x across the x-axis? Reflection across the x-axis, that means I will keep the x value and I will opposite the y. Here, look. across the reflection of x and y, it will be what? I'm keeping the x value and I'm opposite the y value. It will be negative y, okay? So each point from my points here, A, B, C, D, I'm going to put it. Then A dash will be what? I'm keeping the x, so it will be 1. And the y, 2, it will be negative 2. So this is x and this is y. Okay, I'm keeping the x the same and opposite the y. Here, 3 and 6, it will be 3, negative 6. Negative 1 and 2, negative 1 and negative 2. Negative 2 and negative 2, it will be negative 2 and 2. Very good. So don't forget, if he tells you reflection across x, what is the rule? The rule is I'm keeping the x and opposite the y. Okay, take care of this. Okay, very good. Reflect the figure of vertices A, B, C, and D also across the x-axis. You can pause the video and try to solve it by yourself. Okay, just the same as the other one. Did you try to solve? Let's remember what we said. Across the x-axis, what are we going to do? What is the rule? I'm keeping the x and inverse or opposite the y. Very good. Now I'm going to put A, B, C, D and get its image. 3 and 2 to 3 and negative 2. 4 and 6, 4 and negative 6. Negative 1 and 3, negative 1 and negative 3. Negative 2, negative 8, negative 2 and 8. The opposite of negative 8 is 8. Okay, very good. This type of questions is new, so please understand with me and try to concentrate on this type, okay? Find the coordinate of the image of a point. So 4 and 8 and 6 are is the pre-image. 4 and 6 is the pre-image. And he wants the image of it. When it's reflected across, look here, it's not across the x-axis or the y-axis. It's across the line which equal 11. Across the line which equal y equals 11. What this mean? Take care here. We said that in this order pair, this is x and this is y. Okay, so my y equals 6. My y equals 6. Very good. Look here, he wants to reflect in the line which is y equal 11. What is the difference or the distance between 11 and 6? You're going to make 11 minus 6. You will have it 5. Very good. So the distance between the point 4 and 6 to the line which is equal y equals 11 is what? Is 5 units. Very good. What I'm going to do? I'm going to add this 5 units, okay, to my what? I'm going to add this 5 to my y. Okay? Add it to your y. It will be what? So I'm going to add this 5 to my y, which is 11. 5 plus 11 is what? 5 plus 11 is 16. So 5 plus 11 equals 16. This is my new y. This is my new y. My x will not change, okay? Again, if I have a point here and this distance from the point to the line is 5. We said it's 5. From 6 to the 11, it's 5. So its image will be also away with 5. Isn't it right? Yes. So if this is 11, I'm going to add 5 to the 11 to get the image. So it will be what? 16. Very good. And my x still the same. So it's 4 and 16. My answer is C. My answer is C. Very good. Excellent. Let's try to solve this without a figure. Without figure. How can we do this? We're going to see this is my point. and the reflection across the y equals 13. What we're going to do? What we're going to do? We're going to get the difference between the y here in the order pair and the line. So it's what? 13 minus 6. 13 minus 6 equals what? 13 minus 6 equals 7. Very good. So I'm going to add this 7 to the 13. 7 plus 13. This is my new y. Y equals 7 plus 13. 7 plus 13 is what? Is 20. And of course I'm keeping my x the same. So where is 4 and 20? It's B. Of course, if I draw it, look here, if I draw it, this is my point 4 and 6. And this my line, which is equal 13. So here y equals 13. The distance between the pre-image to the line is 13 minus 6. 13 minus 6, which is 7. I'm going to take another 7 in the other side because we said that the pre-image and image has equal distance from the reflection line. Equal distance from the friction line. So 13 plus 7 will be 20. So my image will be 4 and 20. Okay? Very nice. Now you can pause the video and try to solve 20 by yourself. It's just the same. Did you try? Did you try? Okay, let's see it. This is my y. Let's see the distance between the y and the line, which is 4 minus 3. Very good. 4 minus 3, it will give you what? 1. What I'm going to do with the 1? I'm going to add it to the line. So my y, new y, equals what? 4 plus 1. 4 plus 1 would equal 5. Very good. And my x will be the same. So it's 5 and 5. 5 and 5. Very good. So it's D. Excellent. Of course, in the I can plot it in the xy coordinate. Here, it's like this. Okay? Very good. Or you don't need to plot it here. Okay? Again, another one. Find the coordinate of the image of this point. What I'm going to do, this is the y. And here the line is 12. So I'm going to get the difference or the distance. 12 minus 7 will be what? Will be 5. Then I'm going to add the 5 to the line. Then 5 plus 12. It's equal what? Equal 17. 17 is my new y. Very good. And my x will be the same. It will be 1 and 17, which is C. Okay? Very good. Again, another one here. This is the y. You can solve it. 12 minus 3. It will give me 12 minus 3, it will give you what? It will give you 9. Then I'm going to add the 9 to the 12. 9 plus 12. It will give me what? 21. And this is my new y. So it will be negative 4 and 21, which is D. Okay? Very good. Let's complete. Tell whether the transformation appeared to be translation. Look here. Is it translation? What we said about translation? We said that translation is isometric transformation, which needs a vector or a direction, okay, to transfer direction, which is magnitude and direction, okay. So can you tell me that this triangle, it just transformed from here to here? Yes, it's translated in this with a certain distance, or the vertex is in a certain distance, yes. And it keeps this figure and the shape the same? Yes. So it will be translation. Okay? So translation is transformation where all points of the figure moved. Okay? Same distance, in the same direction. So yes. So yes, this is what? This is translation. Excellent. Let's see here. Tell whether this transformation is translation. This translation, look here. I think I can make a line like this, and the figure can flip from across the line. Is it right? Flipping across the line. So this is what? It's reflection. It's not translation. Very good. So no, not all the points moved. Not all the points moved. It didn't move. It flapped. Okay? Very good. Let's see this. Tell whether this transformation is translation. Look here. What happened to the figure? It appears to be reflected. Okay? Look. If I draw a line like this, the figure appears to be reflected. So the figure didn't move. It's reflected. So no, it's what? It's not translation, it's reflection. Very good. Excellent. Let's see this. Tell whether the transformation appears to be translation. This translation in a certain direction? No. What do you see here? I see a point, and the figure, what happened to the figure? It's what? It's rotated across a point with a certain angle. So it's rotation, it's not translation. Okay, I have a point which is the center of a rotation and the angle. Do you remember? If you don't remember, please return back to the lessons in the YouTube channel to revise the lessons, and take care that maybe there is questions will be not from the sheet, it will be from the videos of the lessons. So take care of this. Okay? Okay. So it's not a translation here. It's what? Reflection. So no, it's not a translation. Okay, let's see here. Find the translation of a triangle across V. Look here. This is the direction of the vector. Okay. I have here this. Of course, it's not in the same direction, so B is not the answer. Look, D. It's not in the direction of the vector, so it's not. Look at A and C. You're going to tell me, yes, miss, it's here, it's moved in this direction, and here it's moved. Yes, of course it's moved. But look here, this vector has magnitude. Which transformation here or translation here has a magnitude? Has the same magnitude. You're going to tell me, miss, it's C. Yes, that's right. C. Very good. It's the same magnitude. Okay? So, A is the answer. C is not the same magnitude. Yes, it's the same direction, but it's not the same magnitude. Okay? Very good. Of course, you can draw it by drawing, but you don't need to draw. Okay? Very good. Translate the triangle with vertices. Okay, we're going to start from 28 next session. Thank you very much, grade 10. Please study and try to solve what we already solved together by yourself. Thank you very much. See you for the last